So in this one, we're going to take a look at two cars that collide at an intersection, and the first car is going 15 meters per second to the east, and it's a 1,300 kilogram car. The second car is going north at 17 meters per second, and the cars stick together after the collision. We want to find the final velocity of the cars after they collide. And so, yeah, we're going to have to look at what's going on in the X and Y separately, similar to what we did before with explosions, where we had to look at the X and Y separately. So yeah, go ahead and pause the clip and give this one a try. We're looking at the momentums, conservation of momentum, the X and Y, and the initial velocities as they go. Again, as you recall, mass 1 over here only has an x velocity. So in the x momentum, it does have a velocity, but in the y momentum starting out, it has no velocity. And so, yeah, go ahead and pause the clip and give us a try. And when you're ready to check, you can hit play to continue. All right, so for this one, mass 1 is 1,300 kilograms multiplied by 15 meters per second. Car 2 has no x velocity, so it's just going in the y. There's no x velocity starting out. And then afterwards, we find the final velocity. We factor out v final because they're stuck together afterwards. We add our masses, so we factor out v final. Should get 7.8 meters per second in the x. This is v final in the x only. Now in the y, there is, for car 1, there's no y velocity, so this is 0. And we have our mass times the velocity. We can factor out v final. And so we get 8.16 meters per second. And then, so that's the Vy final, V final in the Y, and this is V final in the X. And we get our X and Y velocities, and we get the resultant as 11.29 meters per second, 46 degrees north of east. Now remember, with elastic collisions, we know that momentum is conserved and energy is conserved, and so we add up all the energy before, add up all the energy afterward, and so therefore when we set these up, we know m1v1 initial, m1v1 initial plus m2v2 initial, all the initials, if we had 3 objects, we put 3, equals m1v1 final plus m2v2 final, and so on if we had 3. And then we also know that the v1s added up equal the v2s added up. And that equation is this one. It's v1 initial plus v1 final equals v2 initial plus v2 final. Back in your junior year, we derived this. You don't need to worry about deriving it. You just need to memorize it, and then remember it's for elastic collisions, and it only works for elastic collisions when we can use that. So here's a sample problem that we'll start with this. We have 2 marbles that come together and hit, and then they bounce apart. And for this one, we want to find out what is V2 final. And then once we get that, we're going to look at the energy before, the energy after, and we'll see if it's elastic or not. That's really the only test that we can have here. And so, yeah, go ahead and actually, yeah, go ahead and pause the clip and calculate for V2 final before you do energy, and then we'll pause there, and then you can try that. So go ahead and pause the clip and get V2 final, and then when you're ready to check, you can hit play to continue. All right, so we should get for V2 final 0.09 meters per second. So now what you're going to do is calculate the energy before, calculate the energy after, and then if they're the same, we know it's elastic. If they're not, then it's inelastic, and so we can find that. So go ahead and pause the clip and give that a try, and when you're ready to check, you can hit play to continue. Okay, so beforehand, we should get 8.657 times 10 to the negative 4th joules. Afterwards, we also should get 8.65 times 10 to the negative 4th joules. And yeah, so therefore it is elastic. Now for this one, we have 2 masses. We have 2 carts on an air cart surface, and the first car hits the second car. The second car is at rest starting out. The first car is going at positive 8 meters per second. Here's our masses. And we want to know, and we know it's elastic. So because we know it's elastic, we know that we can find both V1 final and V2 final because we can use both equations. We can use conservation of momentum, and we can also use our elastic collision equation. So yeah, I'll go ahead and pause the clip and solve for the two final velocities of these carts after they hit, and we'll see what they do. And because it's an elastic collision, all the energy will be conserved. All right, so I just substituted for V2 final, which I substituted into V2 final over here, and then distributed mass 2 to all of that, and then solved for factored V1 final out and V1 initial brought over, and then solve for V1 final, and then we should get positive 2 meters per second for V1 final, and then for V2 final we should get 10 meters per second. And again here, you know, you don't have to do all of the, you know, getting it into equation form. If you want to just start putting numbers in there and you're careful, that's okay. But yeah, and then again, you don't have to derive this equation either. You just got to be able to use it like we did here.